Bohr's quantization condition of angular momentum. According to de Broglie hypothesis, circular orbit can be taken as stationary energy state only if it contains an integral number of de Broglie wavelengths. So we can say that 2 pi r must be equal to n lambda. But according to de Broglie hypothesis, wavelength given by de Broglie is lambda equal to h upon mv. So we can put this value of lambda here. So we will get 2 pi r equals n times h upon mv. Now we can shift 2 pi in denominator and mv to LHS. So we will get mvr equal to nh upon 2 pi. But we know that angular momentum L is given by mvr. So we can write it L equal to nh upon 2 pi. So this condition is called Bohr's quantization condition for angular momentum. It means for permitted orbitals, angular momentum must be integral multiple of h upon 2 pi. Now, let's see the postulates of Bohr's theory of H atom. An electron in an atom could revolve in certain stable orbits without the emission of radiant energy, contrary to the prediction of the electromagnetic theory. According to this postulate, each atom has certain definite stable states in which it can exist, and each possible state has definite total energy. These are called the stationary states of an atom. It means, suppose this is nucleus and electrons move around the this nucleus in certain orbits. Here, if electrons are there, so they will not radiate any energy. But electromagnetic theory says that whenever electrons will go in circular path, so since it will be accelerated motion, so definitely they will radiate energy and finally fall into the nucleus, which is against the proof. Means it is found that electrons don't radiate any energy. Now let's consider second postulate. Bohr's second postulate defines these stable orbits. This postulate states that the electron revolves around the nucleus only in those orbits for which the angular momentum is some integral multiple of h upon 2 pi, as we have proved earlier, L equal to nh upon 2 pi. Next condition is an electron might make a transition from one of its specified non-radiating orbits to another of lower energy. Means suppose this is one level, this is another level. If electron jumps from here and it comes here, then energy difference will be radiated in form of h nu. The same thing is given here. Now let's consider Bohr's theory of H atom. So for this we consider nucleus. Here Z will be taken to be 1 for hydrogen, but here for generalization we have taken here Ze, and this is electron which is moving around the nucleus with a velocity v. Charge on electron is E minus. Now let's find out the expression for radius and velocity. So we know that force on electron due to charge on nucleus will be equal to F, which will be equal to K times, here K is 1.4 pi epsilon naught, ZE times E divided by separation square. So this will become K ZE square divided by R square. Now centripetal force, which makes the electron to move around, will be equal to F equal to mv square upon R. Since this attractive force and centripetal force will be same, so we can say that mv square upon R must be equal to K ZE square divided by R square. So from here we can get mv square, 1 R will cancel out, and this will be k times ze square divided by r, or r equal to k times ze square divided by mv square. So let's apply here the Bohr's quantization condition that states that L equal to mvr. So, and this is nh upon 2 pi. So we can write r equal to nh upon 2 pi mv, and this is r equal to kze square upon mv square, and here we have got r equal to nh upon 2 pi mv. Now we can equate the two. So if we equate, we will get nh upon 2 pi mv equal to k times ze square divided by mv square. So from here, 1 we will cancel out, and we can get the value of v from here. So we take this v to LHS, and then we write 2 pi m in numerator and nh in denominator. So we will get v equals 2 pi k times ze square divided by nh. So we have got the relation for velocity. Now we can put the value of v in equation, this for radius r equal to nh upon 2 pi mv. So putting value of v in r equal to nh upon 2 pi mv. So this value we are going to put here. So it will give r equal to nh upon 2 pi m times value of v. So we can write it by reversing it, nh upon 2 pi k times ze square. So it will become n square h square divided by 4 pi square times m k times ze square. Here all other terms are constant. So we can say radius is proportional to n square. So suppose we put r here, r1, r2, r3, then we will get like this: r1 is to r2 is to r3 is equal to 1 is to 4 is to 9. So we will see other things related to this fact. Now let's find out Bohr's radius. So to find Bohr's radius, we have to put z equal to 1 here and n equal to 1. So putting z equal to 1 and n equal to 1 and r as r0, which is known as Bohr's radius. So r0 will be h square divided by 4 pi square m k times e square. Now we can put the values of all constants, like h equal to 6.6 into 10 to the power minus 34, and m is mass of electron, that is 9.1 into 10 to the power minus 31 kg. Electronic charge is equal to 1.6 into 10 to the power minus 19 coulomb, and k is 1 upon 4 pi epsilon naught, and we know that its value is 9 into 10 power 9. So after putting all values, we will get R0 equal to 5.29 into 10 to the power minus 11 meter, which is equal to 0.53 angstrom. Now, one more thing we can find from here. So let's see the speed of electron. So we have derived the expression V equal to 2 pi k ze square divided by nh. So we are considering the speed of electron in first orbit of hydrogen atom. So here we have to put z equal to 1 and n equal to 1. So, but before that, let's generalize it. So we will not put n equal to 1, just z equal to 1. So v equal to 2 pi k e square divided by nh. Now we can do one thing. We can multiply by c and divide by c. So it will be easier to compare the speed of the electron with the speed of light. So for that purpose, we multiply by c and we divide by c, and we include this c here. So we will get 2 pi k e square divided by ch times c upon n. And let's assume this thing, the bracketed term as alpha. Alpha equal to 2 pi k e square divided by ch. Here, these all are constants, and we can evaluate, so that will come out to be 137. This is called fine structure constant. Fine structure constant. So with this fine structure constant, we will get V equal to alpha times C upon N. So this is the relation which relates velocity of electron with the speed of light. And now here further we put the value of alpha. So what do we get? We get V equal to 1 upon 137 times C upon N. Now we consider the first orbit of hydrogen atom, then N will be 1. In that case, we will get V equal to C upon 137. So what do we conclude? We can say that the speed of the electron in the innermost orbit of hydrogen atom is 1 upon 137 times the speed of light. Thank you for watching.